George here. Every month we will be building an electronics project. This month is a variable power supply. Let's take a look at this month's project. We will be building a variable power supply. This is made by a company called Elanco, and this is their We Make series, tools for makers. Learn to solder and build a regulated variable voltage DC power supply. This has an output of 0 to 15 volts DC at 2.2 amps at 15 volts and 0.3 amps at 12 volts. It takes in 120 volts AC, which is main power. Alright, here's all the components spread out. We have 3 resistors. It looks like 8 diodes, a light emitting diode. We have the rubber feet for the bottom of the case. We got a large capacitor and medium-sized capacitor and several smaller capacitors. This one right here is a 2200 UF capacitor. This is a 470 UF capacitor. This is a, what is this? 120 UF capacitor. And this is a 4.7 UF capacitor. I think all the diodes are the same. The LED, the voltage regulator, and of course a potentiometer. We also have a little seal for the wire, some leads to connect the project's power to, a knob for the potentiometer, and a heatsink for the voltage regulator. Okay, let's start working on this project. First thing they want us to do is to put the label onto the case. Should be pretty easy to do. Peel back the label and stick it on the case. There, we're done. The project is completed. See? Don't believe me? No, I'm just kidding. It's not close to done. Okay. Install the binding post to colors in the order as shown on figure B. Black post will be the negative, and red post will be positive. So these are the binding posts. So I need to tighten it. Grab the red binding post. There it is. It's on the bottom of my magnet. Go figure. Binding post. Red is on the positive and the black is on the negative. It's actually starting to look like a power supply here. Okay, we need to install the transformer. Install the transformer as shown in Figure B. Alright. Black wires going towards the front, and the colored wires going towards me. Okay. Washer, the lock washer, and the nut. I'm just going to loosely tighten that with my fingers at first. So, the black screw. Black washer. The lock washer. And the nut. Need a Phillips head screwdriver. So we'll get my iFixit set and grab out a Phillips head. And while holding the nut down with the pliers, I'm going to tighten the screw. So that's what we got done so far. Got transfer. Cut the red wires and set them aside as we will be using them later. So we'll be snipping red wires off. There we go. Put them aside for use later. Okay, now we'll be working on the circuit board. It's pretty obvious where the big capacitor goes. On the circuit board, they have an indication where the negative and positive is on these electrolytic capacitors. These capacitors are polarized, so the negative end goes on the part that's marked as negatives, usually striped, and usually the negative lead is shorter. So in this case, I'm going to be installing this capacitor on this board. The positive is indicated on this end, so I'll be installing the capacitor like this. I bend the lead so I can flip this upside down, and I'll be soldering that upside down. And in case you're wondering, no, I will not be using the lead-free solder. Lead-free solder is for wusses. Heat the area up, then apply the solder, and it melt nicely. Clean the tip of the iron. Right. That is installed. Looks nice. Snip off the leads. Of course, the lead went flying across the room. Gotta watch out for that. Okay. The 4.7 UF capacitor goes there. 470 and a 220. Go on next. That's the 470. Positive lead, negative lead. Probably should do the resistors first, but we'll worry about those later. It's always a good idea doing the smaller components first, but I'm a rebel. Okay, that one is the 220. There's the 4.7. There's the 220. And move the solder out of the way. Go ahead and solder these. Since my solder holder keeps falling apart, I'll just take the solder off anyway. It's just this other stuff. Not the best soldering job in the world. No, this is one of the reasons why I'm doing this is for practice too. So, I'm not an expert by this at any means. It'd also help if I could see what I'm doing. I'm getting new glasses next weekend, or at least getting the eye exam for it. I funny feeling the glasses had to be ordered. You just don't walk into the eye doctor place and walk out with a new pair of glasses. Usually they have to be lenses had to be made to the script. got things soldered on. That's amazing. Alright. Okay, all the capacitors are installed. Mark them off. C4, C3, C2, and C1. Okay. Now on the board, there's an indication on where the negative side, or what you call the less positive side of the diode should be. So the diodes themselves have a line matching up. See the little gray line? The gray line matches up with the little white line on the board. So let's go ahead and install these diodes. Diodes also are polarized, so it does matter. Diodes only allow current to flow through one way. Okay, let's get to soldering. I wish I could zoom in with these cameras, but they're rather inexpensive cameras. Alright, those components are soldered onto the board. Now I just gotta snip off the leads. Now the resistors, there's 3 of them. 1, 2, and 3. use my multimeter to determine which resistor is which. Because my eyesight's bad enough, I can't really go by the color code. Can't really tell what the colors are. This is 2.17, which is the 2.2K. That'll be resistor 1 that goes on the board. Right here. Okay. Resistors, it doesn't matter what direction they go on. They're not polarized like the capacitors or the diodes. Okay. This resistor here (2.17K) it goes to R4. And this one should be the 150 ohm resistor. Brown, green, brown, gold, that's what it looks like. $147K, or actually 147 non-K. 147 ohms doesn't have a K on it because K would make it 1,000. So 150 ohm resistor goes to there. Next is big capacitor. Let's go ahead and solder all these components on. And let's cut these leads off. So all the resistors are on. Alright. Those two wires, red wires that we cut off from the transformer, are going to be added onto the board here. So let's go ahead and add those. And I realize I'm forgetting to use the fume extractor. Silly me. Should not be forgetting to use that, because this stuff isn't exactly healthy. Lovely. Cut off the leads. There we go. That looks good. Alright, so we got P4 and P3 done. Next, the LM317 voltage regulator, which is this nice little component. And this does go on. The circuit board shows the little, see the box there with the little box on top. The little box on top represents the metal component here. So the voltage regulator goes on like so. Alright, let me bend these leads so it stays on a little better. There we go. Solder this on. This magnifying glass does not give me the depth of scope the microscope does. It's much harder for me to see what I'm doing with a magnifying glass. That is for sure. The eye-hand coordination is just tricky. Okay, now we need to mount the heatsink onto the sounds like the dogs hear something outside. Yeah, this thing works by if there's an overload, you'll overheat, which will cause it to shut down. That's a flathead. Get the flathead bit out. pliers. You can see the heatsink is installed. Voltage regulator is installed. Next thing to solder on is the LED. The LED is a light emitting diode, and just like the regular diodes, it is polarized. And the positive lead is usually the longer one. The negative side is the shorter one, and it's also usually indicated by this flat spot on the end of the LED. It's hard to see in this video, but not always. Anyways, in this particular board, the LED is not going to be in the top of the board, but on the bottom. So I have to make sure I align the negative and the positive up correctly. So what I'm going to do is I'm going to have this. It looks correct. I need to have it sticking up 3/8 of an inch off the board. I guess that's 3/8 of an inch right there. I'm going to wing it. I'm going to use a little electrical tape here. It should hold that in place. Oh, this is going to be so much fun to solder. So you can do this without melting the LED. This side here. See, I sucked a bunch of solder onto the lead, onto the soldering iron, instead of onto the. There we go. That's pretty good. Move the electrical tape set aside. I might need it sometime else. Just cut those leads off. Alright, and the next thing to install is probably the potentiometer, because that's like the last component I have left. So, mark the LED off and a 2K potentiometer. And it also gets mounted on this side of the board. Like so. And solder in place. That I think I can handle. That way. And this is a large enough area that I probably don't need my magnifying glass to see what I'm doing. Set down, let it heat up, and get a big gob of solder. Sit down. Mark that step as complete. Okay. All right. Cut these wires so they're 4 inches. I'm going to say that's about 4 inches there. Using my wire strippers here to strip off the insulation. Don't use your teeth. Some people do. Dentists don't particularly like it when you do that. And you don't particularly like the dentist when he chews you out. So, best solution is not to get chewed out by the dentist. And to prevent from being chewed out by the dentist, don't do stupid stuff like, use your teeth to remove insulation. Right? Yeah. That's always a good word of advice. Don't get your dentist mad at you. This is a piece of junk. Two yellow wires and one blue wire. Cut the red wire! No, cut the blue wire! Cut the red wire! I don't know which wire to cut. It's not like, bomb makers, use a uniform code of what color wires to use for their... It doesn't work that way in Hollywood. Sure. Mm-hmm. Right. In case you're wondering, I'm just tinning the... Alright, so we got a yellow wire, a blue wire, and a yellow wire. And then we got the 2 red wires going off the board here. So according to the instructions, these 2 wires go to connectors there, and then the transformers wires go to the board here. So go in this particular yellow wires and a blue wire. Does it really matter which way the yellows go? I guess not, because it's alternating current. Be my guess. Well, the picture shows the rightmost wire going into this side. And this wire goes to that side. Just see about the tipping tip here. There we go. And then the blue wire goes into the hole here. Go back to poke myself with a loose wire here. It didn't feel too good. So tuning the wires helped, but they also cause a slight little problem where the wire gets a little thicker than the hole. This up just a teeny bit more. There we go. Let's solder all those on. There we go. Okay. Okay, P5 goes to the red one. And P4 to the black. So this wire goes to black and this wire goes to red. And I'll be soldering that. Try not to get my hands in the way. There we go. Washer and nut. The thing's being held onto the board by the potentiometer. Why not? Well, the LED wasn't long enough, but oh well, you can still see it. Alright, so that's what the inside looks like. Turn the shaft counterclockwise. Push the knob onto the shaft. That's pretty cool. Alright, the power cord. Right. Wants us to shorten these wires a couple inches, which makes kind of sense because it's a lot of wire. So we'll do that. So we're about 2 inches long. Should do the job. And then remove some of the insulation. Turn it off, we don't need that on. Yeah, I do need to get a pair of wire stripper. These things are not particularly good. Okay. Feed this cord into the top. Okay, we'll do. There you go, I think we have it. There we go. Come on. In you go. There we go. Ah, that was a lot of work. Put these heat shrink tubings back on. See, I got a little ahead of me on one of the steps here. Alright. So, we got the power cord fed to the case. And the next step is to twist these wires together and solder them together. Which we can do easily. Put off this extra wire here. Alright. Now I could test this with this circuit exposed, but that side dangerous. That side relatively safe. I think we'll just assemble the power supply here and be on the safe side. Alright. In theory, this thing's done. Well, we have to put our feet on. So we will do that. We'll put them next to the screw holes instead of over the screw holes, because it really drives me nuts when you can't take the screws out because they put those feet over them. Sure, you could remove the feet, but then they don't stick properly afterwards. So I got my rubber feet. So let's see if this thing actually works. My guess, it'll probably blow up on us. We're going to stick it in power. Well, there's no smoke. That's a pretty good sign. Okay, 67 milliamps. Okay, right now we're at the 5 volt settings, and it says 5 volts. It's actually going up to 18 volts, 17.88 volts. This power supply is definitely working. So it's putting 17.88 volts out max.